What is up to you guys? It's me, Paul Balmedina. I hope you had a fantastic day today. And I'm here to talk to you about Grade 7 Mathematics and Philippine K-12 curriculum. And in this video, I'm going to show you the principal root of a number and its nature. But before we do that, please do me a favor, smash the like button and do subscribe. So without further ado, let's go hop in and enjoy learning. Peace! Okay, under the principal root and irrational numbers, there are two lessons to be discussed. Lesson 1 is all about principal roots and its nature. Lesson 2 is all about determine what two consecutive integers the square root of a number lie. In this video, we will be only discussing lesson 1, principal roots and its nature. So here are the questions we need to answer. Number 1, what is principal root? Number 2, what are the signs and notations? Number 3, what is rational and irrational numbers? Now let's talk about the signs and notations. So as you can see, we have a bunch of letters and symbols. So here is what we call the index. This one is what we call the radical sign. Here is the radicand. And here is the principal root. So in the signs and notations, you already know or you have the idea of what the principal root is. Okay, but now we have to talk about first the quantity of a number multiplied by itself. Let's have these examples. Let's say we have given number 1, 2 times 2. You know the product 2 times 2 is 4. But in vice versa, if we have the square root of 4, the answer will be 2. So that is the principal root of square root of 4. Take note, class, that if we have no index visible or it has no index, it means square root. Number 2, given 4 times 4, the product will be 16. So the square root of 16 will be 4. If we have 3, 7 times 7, 49, the square root of 49 is 7. If we have 8 times 8, the answer will be 64. So that is the square root of 64 will be 8. So number 5, if we have 10 times 10, that is 100. So the square root of 100 is 10. All the derived products are considered perfect square. So perfect square are numbers that have rational number as principal roots. Taking the square root of a number is like doing the reverse operation of squaring a number. So but if you multiplied a number several times, let's say 3 times, 4 times, so consider the given below. Given number 1, we have 1 times 1, the product will be 1. So the nth root of b, since you multiply the first number or the given twice or 2 times, that is only the square root of 1. So the principal root will be 1. If you multiply 3 2 times or 3 times 3, the product will be 9. And remember, the index will be 2 because you multiply 3 for only 2 times. So therefore, that is the square root of 9. The answer will be 3. But if you multiply 6 for 3 times, the answer will be 216. So that is 6 times 6, 36, times 6, 216. So therefore, the index will be 3. So this will be read as the cube root of 216. So the cube root of 216 is 6. Given 9 times 9, the product will be 81. Since you multiply 9 2 times only, the index will be 2. And consider if it is 2, it will not be written but read as a square root. So that is a square root of 81. The answer will be 9. Number 5, if we have 5 times 5 times 5, you multiply 5 3 times, the answer will be 125. So the cube root of 125 will be 5. Remember that principal root is a number which produces a specific quantity when multiplied by itself. It is the positive nth root of a number. But what if you have this principal root? Here comes the rational and irrational number. So rational numbers is a number that can be expressed in a over b form, where a and b are integers and b is not equal to 0. In elementary days, a over b form is the lesson in your fraction lessons. So what are rational numbers? So these are the examples of rational numbers. It can be any of the following. Whole numbers are also rational number. Those numbers 0, 1, 2, 3, 4. Integers can be rational number, counting numbers, and decimal numbers. However, irrational number is a number whose decimal representation is neither terminating nor repeating. This number cannot be expressed as a quotient of two integers. So what are those irrational numbers, which is non-repeating and non-terminating numbers or decimal numbers? For example, we have the following. Take note that any number that cannot be expressed as a quotient of two integers is an irrational number. The numbers square root of 2, pi, and the special number e are all irrational numbers. So let us now proceed to classifying principal nth root of a number as rational or irrational numbers. Once again, to determine whether a principal root is a rational or irrational number, you need to determine if the radicand is a perfect nth power of a number. If it is, then the root is rational. Otherwise, it is irrational. Now let's have these examples. So we need to tell whether the principal root of each number is rational or irrational number. So we have the given 5 items only. As you can see in the given, we do not have any index visible. So meaning we are only looking for the square root of the number. So what is the square root of 1000? So the answer will be 31.62 and so on. Meaning that principal root has a non-terminating and non-repeating decimal. So therefore, it is a rational number. How about square root of 0.04? The answer will be 0.2. So since it is terminating, the answer will be rational. And what is the square root of 3969? The answer will be 63, a whole number, therefore rational number. How about number 4, square root of 81? So the answer will be 9 and also a whole number, so therefore a rational number. But however, we're looking for the square root of 2. The answer will be 1.4142 and so on. Once again, if you have this kind of non-terminating and non-repeating decimal number, the answer will be irrational. So there you have it. Thank you very much for your time and for listening. God bless you.